All right, welcome to our second video. So this is going to be a little bit of a longer video. It's basically the packet that we would have been working through in class. So we're going to start by just refreshing. I know you literally just watched the other video, but side postulate. If three sides of one triangle are congruent to three sides of another, then the triangles are congruent. So that's that postulate that we talked about in the previous video. Over here, they just want us to label which side pairs are congruent. So I can see that side AB and side DE. So if AB is congruent to DE, if BC is congruent to EF, and our last pair of sides, AC and DF, if all these statements are true here, then that is enough to say that triangle ABC is congruent to triangle DEF. All right, so here's our first sample proof. We're going to start with our given. So PQ is congruent to ST, that's a given. QR is congruent to TR. Okay, they happen to split these up. I'm also going to label things on my diagram. So PQ and ST are congruent. QR and TR are congruent. That's the other given. And then R is the midpoint of PS. Well, what does it mean to be a midpoint? Because that's just a given. Reminder, anytime you see a word like bisector or midpoint or something like that, chances are we're going to use that as a reason. Well, a midpoint cuts something exactly in half. So I can use that to state that PR is congruent to RS. That's our next statement, and that is definition of midpoint. So now I have three different pairs of sides, and I'm saying that they're congruent. That's plenty to say the triangles are congruent using our side postulate. And you're welcome to just stop at SSS. That's plenty of information. All right, let's move on to proof number 2 down here. So this is this bow tie shape. And I did say, hey, sometimes we'll use that to prove something about vertical angles. Not all the time. So let's see where this proof is going. So they're telling us that JL is congruent to NN. That's given. They're telling us that K is the midpoint of JN and LM. That's another given. Okay, only because they're talking about midpoints here and we're talking about side proofs, I'm thinking maybe we're not going to do anything with angles here. Okay, if K is the midpoint of JN, it means that JK and KN or NK must be congruent. So that's definition of midpoint. But K is also the midpoint of LM, which means LK must be congruent to MK. Same exact reasoning here, definition of midpoint. Now, if this was a blank proof, you would be more than welcome to combine these two steps into one row. And honestly, you could combine these two in another row and shorten the proof. For these ones, we're just splitting things up just to make sure that all the steps are a little bit clearer. So now that I have these three statements, I have three pairs of congruent sides. That's enough to prove the triangle is congruent by SSS. All right, we're going to keep on going. So on to number 3. For number 3, we do have a shared side over here. We might use that shortcut that I talked about in the previous video. Let's start with our givens. AC is congruent to AD. Now they're giving us 4 spaces here, and they're already telling us that we have 2 pairs of sides that are congruent. So I think I'm going to split up my givens here just based on the number of steps. So AC is congruent to AD. CB is congruent to DB, our other given. Okay, let's go ahead and use our shortcut. I can say that AB is congruent to AB. That's using our reflexive property. Something is congruent to itself. I have 3 pairs of sides congruent. That's plenty to prove that these 2 triangles are congruent. Triangle ABC is congruent with triangle ABD, and that is by SSS. All right, let's move on to some more side angle sides. So remember, this postulate states that if 2 sides in the included angle, included is a keyword here, if 2 sides in the included angle of one triangle is congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. So here we see that if AB is congruent to DE, if angle B is congruent to angle E, and if BC is congruent to EF, then that's plenty of information to go ahead and say these two triangles are congruent by side, angle, side. So ABC is congruent to triangle DEF. All right, and again here you can see bolded, all caps, included is the one between the sides. Okay, so a couple sample SAS proofs, SAS. First step, given. JM is congruent to LN. Next one, given. They're also telling us that JMN, this angle over here, is congruent with LNM, that angle over there. I see a shared side here, so MN is congruent with itself. That'll be using our reflexive property. Now I have two sides and the included angles, so I can state the triangles are congruent by SAS. All right, I'm going to go through one more proof, and then I am going to leave you guys some time to work on some problems by yourself. So we'll chat through the rest of this packet, but let's do this proof number 5 first. So we're going to start with our givens. AB is congruent to CB, given. AB is congruent to CB. And then BD bisects, keyword, right? Ding, ding, ding. If you see bisect, probably going to use that as a reason. So that's our next given. What does it mean to bisect? Well, to cut something exactly in half. And they're telling us that we are bisecting angle ABC. So that must mean that these two angles here, ABD and CBD, are congruent. And that's what we see for our next statement over here. So that is using definition of angle bisector. All right, I do see a shared side here. BD is congruent to BD by our reflexive property. I have a pair of sides, pair of angles, pair of sides, and the angle is included between those two sides. So that's plenty to say these triangles are congruent by SAS. So here's what I want you guys to do. I want you guys to take a moment, work through proof 6, 7. Oh, darn. Okay, work through those two proofs. And let's take a look at the rest of the packet. It's a pretty big packet that I gave you guys. Over here in the triangle congruency section, you're stating whether or not the triangles could be proven congruent. So right now, our only postulates are side, 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 or side, angle, side. We do have some other postulates that we're going to talk about, but for right now, just assume, hey, those are my only ways to prove. So if I have all three pairs of congruent sides, cool, yes, I can prove these are congruent by side, side, side. Also, they're saying write a congruency statement. So for instance, let's just go through example 2 real quick. I have 1, 2, 3 pairs of congruent sides. So yes, by side, side, side. These can be proved congruent. And then make sure when you're writing your congruency statement, I could say triangle ABC is congruent to triangle. Okay, if I'm starting up here at A, then I went to B, then I went to C. Well, side AB is congruent with side CD over there. So this is going to be triangle C. And then if I said ABC, I would want this to be triangle CDA over there. So feel free to double check yourself. Make sure that this is going to make sense. ABC, I did my 2 tick mark line first. And then I went from B to C, that's my 1 tick mark line, so that should correspond with D and A. And then we did our 3 tick mark line. So just make sure with your congruency statements that the letters should match up. So you guys can fill in the rest of those when you're done watching this video. Down here, kind of interesting, they are showing some stuff about parallel lines. That's what those little symbols mean down there. We're not quite there, but eventually we're going to be combining what we know about parallel proofs and parallel angles and pairs of parallel angles with what we know about some of these congruency statements and some of these new postulates. So for this one, right, if I have 2 parallel lines and a transversal, well, I can state that this pair of angles over there is a pair of alternate interior. They must be congruent, okay? So I'm kind of pairing what I know about parallel lines with some of these new triangle diagrams. All right. Then once you guys are done with that, so finish those 2 proofs, finish the rest of the triangle congruency. The rest of this packet is just more proofs. I want you guys to give these a try. So do what you can. We will have plenty of time to go over some of these tomorrow in class. Your homework is literally more proofs. We are just in the depths of triangle proofs right now. Let yourself enjoy the puzzle a little bit. Try not to get too bogged down. Again, use some of your shortcuts. Like for proof 10 over here, there's a chance that I might say something about LM being congruent to itself, right? That might be helpful. Over here, same thing, right? I have a shared side. Maybe that's going to be helpful. I don't know. We'll see. They're saying, hey, something is a midpoint. Okay, I want to use that. So use your clues. We should be able to accomplish these within the number of statements given here. All right, so work through that. And then for the rest of your class, down here, now this one is funky. Using side, 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 or side angle side in the coordinate plane, this is a little different, okay? So determine whether these two triangles are congruent. If I'm thinking about using side, 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 well, I want to state that sides are congruent. In the coordinate plane, I could do that by finding lengths or finding distances. So for these problems, you would be using your distance formula, okay? So here they're specifying triangle PQR and triangle XYZ. You want to start by figuring out, hey, what's the length of PQ? Remember that your distance formula is this big square root of x2 minus x1 squared plus y2 minus y1 squared. If I'm looking at these first 2 points, I'm going to call that x1, y1, x2, y2, and we can go ahead and plug these in. So I'm going to get negative 3 minus 5 squared plus 7 minus negative 4 squared. That's going to give us negative 8 squared plus, 7 minus negative, or plus 11 squared. It's going to give us the square root of 64 plus 121. Keep going with this. Either do the mental math or I'm pulling out a calculator because it's the afternoon and I'm tired. So 64 plus 121 is going to give us the square root of 185. Can we simplify that at all? Can I just take the square root of 185? No. Is there anything that I could factor out or simplify here? It's not really factoring. Well, 185 can split into 5 and 37. Neither of those are perfect squares, so I think that's as far as I can go. So I can say that PQ equals the square root of 185. What you want to do from here is you want to compare that to xy, plug everything in for xy. So I'll call that x1, y1, x2, y2, 9 minus negative 2 squared, plus 7 minus negative 1 squared. Am I going to get the same thing over here? So I have 11 squared plus 8 squared, square root of, it looks like we're getting the same thing, right? 121 plus 64, cool, that's giving us 185. So xy also equals the square root of 185. So it looks like we have one pair of congruent sides. Keep going with this. Also check this pair, also check this pair. If you know that you have 3 pairs of congruent sides for these triangles, then that is plenty of information to state that these triangles are congruent. But if you have just one pair that doesn't have the same lengths, I cannot state that those triangles are congruent. So in class, you guys are going to be finishing up whatever blanks remain in here. So we did, I think, 5 proofs together. Finish up these 2 proofs up here. Oh, I'm going to sneeze. And this is not a professional quality video. Hope you're enjoying that. Finish the triangle congruency. Try these proofs. I think this is probably plenty to keep you guys busy during class today. Any questions you have, we will have plenty of time to go over it tomorrow. So I'll see you guys then.